Homework number 3, 3-24. It was about the heat transfer through a window. My assumptions were thermal conductivity is consistent. 1D, I drew my picture of my resistance diagram, and then figured out my area, figured out my resistances through the different materials slash fluids, and then figured out my resistance total. Was able to determine the heat transfer through the window by doing T infinite minus T infinite 2 over resistance total, and then was able to determine the inner surface temperature of the window via the same relationships. And then 3-73, the weird problem, my assumptions were heat is transfer is 1D, constant thermal conductivity and radiation you can just ignore. There's my picture, there's my resistance diagram. I was able to determine that the wood and I think the fiberglass were in parallel, so therefore you would have to do the other weird relationship for resistances in parallel. Then you can sum them all up, get resistance total, and then from that you just use the heat transfer relationship, and then you're able to determine how much heat was transferred through. I think it was for one section. So then you have to multiply times the complete area to get the Q total. 3-94, it was about hot water flowing through a cast iron pipe. So then my assumptions are 1D, constant thermal properties. There's my resistance diagram, figured out my different areas, figured out my resistances, figured out my H radiation, and then from that I had to, for some reason, do H combined of the H radiation plus H convection, which I was very confused about. So I looked at the answer, could do that, about why they'd even summed them. And then I figured out my resistances. And then it was similar relationship again to figure out the heat transfer. And then from that, you're able to determine the average velocity of the water from the other relationships. And then for 14-57, it was H2 in air with a membrane in between. And it basically asked to figure out the mass flow rate of the hydrogen, like going through different thicknesses of membrane. So you just had to figure out the equation for, I think it was, I don't remember what it's called, but it's right there. And then that's it for 2 millimeter, and then for 5 millimeter, you do the same thing.